Welcome everyone to this last talk of the morning session. We've got David Merce from Los Angeles. David is a board member of the Python Software Foundation, and he also is the author of a book on text processing with Python. He spoke at multiple PyCons all around the world, and he's going to talk to us about text processing in Python. Please give him a warm welcome.
Thank you so much. So the talk I'm going to give today, in a way it's structured a bit less than some other talks you may hear that I've given other places, where a lot of good talks have beginnings, middles, and ends, and they try to prove something. But in this case, I just think that Python 3, I think Python is great, but I think Python 3 is really great, and I know that some people are using it and not enough people are using it, and we're getting towards adoption. So I just sort of look at a bunch of things that I think are really cool that have been added recently in Python that weren't there in earlier versions. I say something like this on the slides. Well, I mean, it keeps getting better. In 3, of course, one of the crucial changes is the byte Unicode distinction and how you handle text processing, and especially how you handle Unicode text differently now. And I have a few slides that I'll talk about that. But there's also a lot of just neat standard modules and neat built-in functions that have been added to things. And I'm sure I'm not going to get to all of them, and if people have ideas at the end about other ones I might have talked about, that would be great. Yannick mentioned introducing me, and it's true. A very long time ago, when my hairs weren't as gray, I wrote a book a decade ago called Text Processing in Python that was all the cool things you could do in Python 2.2, basically, just sort of as 2.3 was coming out, with maybe a couple mentions of that. And nothing is that much different from way back then. Way back a decade ago, you could do a lot of amazing text processing things with Python, and you still can, and a lot of them are easier than they used to be. I probably don't need to show you some URLs. Everybody can find those on their own, but these are fascinating documents. And there's a lot of little details that I learned a lot actually reading these in preparation for the talk in the last week or two. That, some of the clever core developers, whom I'm not one of, think of really neat things to add into the new versions, and it's easy to miss them if you're not reading these particular documents. I think I just mentioned on the earlier slide, a lot of this stuff that is really neat that's been added in 3.1 and 3.2 and 3.3 has been backported. And so with the 2.7 series, which is, I don't know for sure, but we'll probably have 2.7.4 at some point, and now certainly we have 2.7.3. When there's cool ideas which don't require the sort of structural language changes that are needed for the newer Python versions, someone backports them and they actually become part of the 2.7 series. So a lot of the cool things I talk about, you actually can do. Maybe you can't do in 2.7.1, but you can do in 2.7.3, or you'll be able to do in 2.7.4. So it's not strictly what the talk advertises that you have to use the Python 3 version, but you still should. It's better, and it's where things are ultimately going to be. But I actually think the chronology is a little bit interesting, and I guess you should memorize it, and you'll be quizzed at the end on it or something. That 2.7's moderately old, but 2.7.3 is quite new. It's not quite as new as 3.3, but it's it's newer than a number of the 3-point versions. Okay, so I'm going to do a few slides, and I love the collections module, and I know a lot of you are probably at Raymond's, several talks, and this is basically all Raymond Hedinger stuff that I'm going to talk about, and he's done amazing stuff with a lot of this. And most of it's useful for everything you want to program. But in particular, since this is a lot of what I do and what I'm talking about, I want to tell you why these cool collections are particularly useful for working with text processing kinds of things you might do. So the first one I want to talk about is named tuple, which I'm absolutely in love with and I've used since, when did it come out? I mean, it came out 5 years ago or something first in some version. But I've actually just really started using it a whole lot because just in the last year I've had some tasks that deal a whole lot with CSV and a whole lot with databases, which I hadn't played with as much before. I mean, I have, but not anyway, in a particular project. And it's such a nice thing to automatically reach for, to make any tuple a named tuple, because it's just a more useful object that's easier to work with. And it's a subclass. It works in the same way. You have, probably everyone knows this, but just to repeat it, you can still index into it and slice it and all the things you'd expect with a tuple, but you can refer to the attributes of your named tuple with attribute names. So I give this little example where I'm using named tuple sort of in conjunction with the CSV module, that I open up a CSV module and I use the CSV reader to parse it out. But then so I do a little bit of a clever thing. I read one line out of it because I'm assuming the CSV file I'm reading has a header line in it, which, it may or may not. But assuming it does, I can use that header line to get the names of the fields in the named tuple. And then it works generically on any CSV that I'm going to read. Of course, once you go back in your later code and you actually want to refer to those, you sort of have to know. I mean, if you want to say user.first, there has to be a first as a field name. And this is, small sample code, and you can deal with that in different ways. But there's also this cool thing called rename, which I believe you only get from either 3.2 or 3.3. And I think it's not backported yet, but someone can look it up. And this lets you do this sort of thing that I do on this slide, that what it does is if you set rename, then when it looks for the field names, it'll accept field names that aren't okay as Python attributes. So if you have one that's a reserved word, like, you have a header that's called def, or you have a header that's called, percentage, or that's the header that's called 37, it'll give it a new name, which are just going to be sequential _1, _2, _3 to fill in the positions, which are obviously not as elegant to refer to, but at least you have your named tuple, no matter what you pass in as the potential field names. And then, you can see in this, I just print off a bunch of results from this, which are nice. I mean, probably you can recognize first names and last names and ages as probably being what they are if you just had the values, but now you get actual names for them. And you might think that doing this as a dictionary would be a cool way to do it, and it's not terrible, but use a lot more memory with dicts. A named tuple keeps the field names in the class, and you don't have to worry about eating up lots of memory by repeating the key names. So that's neat too, and if you ever want to convert one of these to a dict, there's a method called asdict to do it. Counter is another class that I like, which is newish. And I guess I'll just show you. So one of the reasons I'm showing you this slide is because this most common method is a new thing too, that you need 3 point something. But this counter is friendly. It's a sort of dictionary, but it's a sort of dictionary where you want to keep aggregate counts of things that you're looking at. And you can do that with default dict, and you can do that with the, get on a regular dict and having a default value of 0, then adding to it. And this is just sort of nicer looking, and you should use counter. But one thing I love from a text processing point of view is you have histogram, which is spelled most common, built in as a method for a counter object. So this is, I think they use this example in the standard docs about abracadabra as a word, but so I'm just counting up the occurrences of the various letters inside this word abracadabra and then printing out a histogram of how frequent those letters are. There's also this cool thing, and this actually does need 3.3 specifically, is you can use your minus equals and plus equals, probably times equals too, I'm not actually sure, on keys in the dictionary. So I've here the D, which had occurred one time, I'm bumping it down by 10, so you can see that now it occurs only -9 times, which, depending on your context, -9 may or may not be something meaningful, but maybe it is. I mean, maybe you're having an account and you get into a deficit if you're in negative numbers, and that's something that's still meaningful to count. So this is just really nice syntax for working with this stuff. We also now get some pseudo-arithmetic stuff, which is in new versions, and some of it's in 3.3. So I made a second counter here, you see, and I have another phrase that has some of the same letters in it, and I can add those together and do a combined histogram. So you can verify that's true, but so you just, add a counter to a counter, and it gives you a combined counter, which is nice and what you'd expect. It also has this unary operator, the unary plus, which gives you only the positive values of the counter, and the unary minus, which I don't show here, gives only the negative values of the counter, and that's a nice friendly thing. It's also worth noticing that counter is a kind of default dict, which defaults to 0, so that I've never added an X to either of these counters, in particular not to C1, I guess, but you can still get the 0 value as a default. Now, this is a collection that is, again, brand new, and I really love, and Raymond talked about it yesterday. ChainMap is a collection of mappings. So rather than have your dictionary that you have to accumulate a bunch of things in, you create a dictionary and you update it with this and update it with that and update it with the other thing, you can just have your various dictionaries or anything that acts like a mapping and just chain them together. And what happens is that when you do a lookup into it, it looks through the first dictionary and then it looks through the second dictionary and so on until it finds the thing it's looking for, or of course it may not find it, and then it'll have the normal behavior of raising an exception. And you can look at the examples that show that happening. But an interesting thing, and this is just sort of a footnote, and I don't think anyone's really going to do this, but ChainMap can include chain maps in the mappings within it, and this is weirdly magical because this is actually exactly what object-oriented programming with inheritance is. This is actually a method resolution order right here, so that you could, in your chain map, store not just a bunch of letters as keys, but have names that map to functions and look up all the functions in a resolution of where you find them. And I call it child here in the slide to sort of give that idea, but you could have, grandchild, which had as somewhere in the chain its child and so on. And you can actually do all of object-oriented programming right here with this one collection, which is sort of nice to see what's behind the scenes. It's not actually what's behind the scenes in actual Python, but to think of it as being so little that's going on. Okay, so people maybe know this, maybe don't. List comprehensions way back in Python 2.3 were such an amazing construct, which Python borrowed, which Raymond borrowed from Haskell and from mathematical notation in general. And they're one of the things that make Python so expressive for a long time. And it's just so nice that that's been added to other types of basic collections, that, basic data types that we're interested in. So I actually haven't used this much. And this is something that now that I've done the slides, know I should use, but you should as well. You can do comprehensions with dictionaries, and you can do comprehensions with sets, and they look just the way you'd expect them to look. If it's a dictionary, it's a key and value separated by a colon, and I don't show it, but you can have if clauses and all the rest. So it works just like a list comprehension would work. And anyway, for a set, it's the same thing, but without the colon. And I also showed this. This is not, of course, a comprehension, but I don't remember when you could start doing this, but you used to always have to create sets by using the actual set type and then pass in a iterable to it to create a set. And now you just have a literal expression for a set, which is just much prettier. And I like it. But here's a little inconsistency, which I understand the reasons for, but it does kind of stand out, that you might expect that when you put parentheses around something that looks like a comprehension, you'd get a tuple comprehension, which, conceptually could be a thing. But you don't, of course. You get a generator out of it, which is a good thing to get because it's lazy and it doesn't instantiate except for element by element, and it has all the nice properties you'd want, but it doesn't have there's no way to express literally a tuple comprehension. You can, of course, pass that thing to tuple as an initializer and you'll get one, but there's a slight difference in syntax. But anyway, these are beautiful expressions which make Python prettier. Okay, so I want to talk about Unicode, and this is, in a way, central to why you should use Python 3 and not Python 2. Unicode is really hard, and anybody who thinks they get it right probably doesn't. But we get pretty close here. I saw a wonderful talk last summer at OSCON with Tom Christensen, who's famous particularly in Perl circles, who talked about Unicode in a bunch of languages, in Perl and JavaScript and Python and Ruby and Java and something else. He had a list of them, and he went into a lot more detail than I began to understand, but basically all of these languages get a lot wrong in Unicode, and it's impossible to do things right. And I don't know if we quite come the closest with Python 3, but we do pretty good. And we probably don't do some things right. But here's sort of the basic explanation of Unicode. There's I mentioned on this slide or the next, but there's a thing called the basic multilingual plane, which is the Unicode code points that fit in 16 bits, more or less. And that's a whole lot of them. That's the Roman characters and the Cyrillic characters and the Greek characters and the Han character, the basic Han characters, and most of CJK and Bengali script. And it's sort of the most common things in most human languages, but actually the folks who care about this have found even more characters than will fit there, than in 2 to the 16th positions. And so not everything is in the basic multilingual plane, which means that if you want to go bigger, you have to use escapes and variable lengths, and it's sort of convoluted. And there's also substitution characters and how diacritics are handled, and there's a lot of nuance there, which I can't do in this talk. But here's a thing in particular. As everyone in the room knows, in Python 3, the basic string type is a Unicode type. It's no longer this division between Unicode and string and trying to convert between those in odd ways. And that Unicode string, which is the basic string in Python 3, or in whatever language, has to be encoded somehow internally. And we have a couple options about how we could potentially do this. We can use a fixed width encoding, which is what we did until Python 3.3 actually. And sort of the default, which was called the narrow build, was to encode all the strings as UTF-16, which is also called UCS2, which is to say we're going to give 2 bytes to every Unicode character. And, well, that seems like it makes sense. And then there was this concept of the wide build where we would give 32 bits, 4 bytes to every Unicode code point. And there'd be incompatibilities between narrow builds and wide builds of Python, and they perform differently on different platforms or in different distributions, and it's really a mess. But there's not any obvious good solution. If you use a wide build, if you use 32 bits to encode every Unicode code point, you fit everything, that's fine. And because it's fixed width, it's really easy to index this. You just take your index and multiply by 4, and you know where it is you're going to get your code point. But it takes up 4 times as much memory as you usually want when you just want to have a bunch of ASCII characters, which a lot of the time you do. You can use UTF-8, which is always compact, but the width gets longer very often. Or you can use UTF-16, which gets you the worst of everything, because you kind of, sort of, most of the time fit things in 16 bits, but sometimes you don't, and you have to have these surrogate pairs in escape. And so everything's broken, and you shouldn't use that. But I sort of want to, if people want to understand Unicode, I think this slide actually goes a long way towards understanding a bit about encoding. I have this Han character that I have no idea what it means. I found the example somewhere, and I don't know if there's anybody who recognizes it in the audience who can tell me what it is. Do you know? But is that, what does it mean?
KU. Japanese KU.
What does it mean?
No, sound.
Sound? Okay, I'm glad it didn't mean something obscene or something I didn't want on my slide. I can do sound. In any case, I have this character which is not in the basic multilingual plane, and I have a ASCII character that I put here, and I can encode them both as UTF-8, and it kind of does what you'd expect. The M takes one character, one byte to represent, and it just is what it looks like, because the ASCII characters get this sort of privileged position in segment 1 of the of the whole basic multilingual plane, and that's nice for the ASCII characters you deal with a lot. This other character that's long, well, first it has these prefix bytes which show the endianness of the platform on which you're encoding it, and so you can kind of ignore the, actually no, that's only for the 60 and 32, but you have the F0 at the beginning is sort of the escape character, and you use a bunch more bytes to encode what this coup character is. And that's okay. It's compact when it can be, and it's not compact when it can't be. But in UTF-16, you get this sort of nasty story where you use the prefix bytes, the FF, FE, and that just comes at the beginning of the whole string. So if you had a long string that was not just one character, that would just occur once. So it doesn't have a lot of overhead unless you have very short strings. But then you just have 2 more bytes, the actual letter M and then a null byte to encode the letter M. So effectively, discarding the prefix, you have 2 bytes per character, and that's reasonable for the ASCII character and for anything in the basic multilingual plane. But here you have this coup character that's outside of the BMP, and you use this weird number of bytes to encode it. I mean, it's twice as many, discarding the prefix. And you really don't know that except for well, you just don't know that. I mean, you can look up the character and where it lives, but it's a pain. Okay, so you can code in UTF-32, and everything gets encoded in 4 bytes, and it's really long, but it's uniform. So we have this magic now with PEP 393, and Benjamin Peterson had a whole talk about this yesterday. Am I doing terrible on time? Yeah, okay. So what we get now is Python smart enough to encode every string it sees in the most compact way that's reasonable given what's inside it. It looks through the highest Unicode code point that's in it and picks a representation internally, and everything doesn't always get faster in micro benchmarks, but overall in a large program, you're going to use a lot less memory and a lot more things are going to fit in cache, and the program's going to run a lot faster now in 3.3 than it did in anything before, so you have to pick this version. I can kind of skip over this. Unicode itself changes, lots of things get added. If you're dealing with a lot of real multilingual stuff, you want to kind of keep pace with that, and the way to do that is to pick the newest Python version, pick 3.3. Here's something that's absolutely ancient, and actually, how many people in the room know this is true? Raise hands. So, I learned this, when it first came out, and I actually read the What's New in Python 2.4, I think. And I knew this for a few months, and I completely forgot about it. And I spent 7 years over and over writing for prefix and prefixes, for word and word. If word starts with prefix, do something, and then you have nested loops, and you have to worry about the break conditions and things like that. And I've done this wrong hundreds of times, and this is the right way to do it, and it's beautiful. I mean, you can look for multiple prefixes just with one method call. It's a little bit weird because the tuple of possible prefixes is a tuple. It's not anything else. It's not a general iterable. It's not a list. It's a tuple, which seems to maybe not quite fit the pattern of method calls because there's no reason it can't be an iterable. But in any case, same with ends with, of course. So this saves you code if you just do this. I love TextWrap too, which is an old module. It's not in 3, although they've added a few things, and I make a couple comments here on the slides about things they've added. But way back when I wrote a book about it, and for years when I was using older versions of Python, and even since, and I see in a lot of code where people re-implement, including me, TextWrap over and over again, slightly less well for a one-off purpose. Because, well, this case seems so simple, I don't need to use the module, or use the module. It's great. It doesn't do that much, but what it does right. So I show a little example here where this is the fill method, which has been there for a while, and it lets you do indentation, and it lets you wrap to a certain width, and there's some more options about whether you can split words and things like that. Read the documentation about it, but it's nice, and rewrapping text is something that is okay. Here's a thing to do with TextWrap that I should do a lot, that I fail to do a lot of times. I write multi-line strings very often for blocks of text that are somehow I'm going to process in some manner, and of course having triple quotes is one of the really nice features in Python where you can put multi-lines, and in this case I'm kind of thinking of them being multiple lines where I actually care where the line breaks are. But it's really ugly to put your triple quotes and then move the block of text all the way to the left so you don't have extra spaces or tabs at the beginning of it, and then deal with that. Yeah, I don't know, it just looks ugly in the code, but it doesn't have to because you have in TextWrap this wonderful dedent method. So just go ahead and indent your whole block of line-oriented text however far you'd like to, consistently, and then just dedent it at the end when you're done with it. And one case where this is particularly common, although by no means the only, is in doc strings. I know that everyone puts a doc string at the top of every class and every method that they, or function or whatever they write, and you want to get the help on it, you want to use a debugging tool or an IDE or something, and you don't want the weird indentation that's scattered in the doc string, but just get rid of it. The tab size. The indent is, I think the indent is brand new to 3.3 when I looked it up. Okay. But whether or not it's new, it has some new options to it. And one thing that's really nice is this predicate option. So I'm imagining that this is an email message and that I started out with as message, and I want to do the thing that you usually do in email messages, where you say who said it and then you quote the stuff underneath. In this case, you could do something different with the first line from the other lines, but it's cool that indent takes a predicate, so you can use whatever function you want and use that to calculate whether to indent that line, which is a nice kind of functional programming-ish sort of construct. Okay, here's a nice module that has some stuff added to it and has been nice for a while. HTML entities, if you work with web stuff, then these entities have names, and there's, in particular, in 3.3, there's a dictionary called HTML5, which is added, which there's a whole lot more entities to find in HTML5 than there were in previous versions of HTML. And these are just a bunch of dictionaries, and they're really easy to work with. So you can find by name what's the Unicode character that corresponds to a HTML entity name, and entity defs is the pre-HTML5 version of the same thing. And you can also look up the name of a character from its actual Unicode character, but you have to do the ORD on it. But still, it's simple. So it's an easy way to convert between actual Unicode characters and HTML entities that you're going to have to use to name them. Oops, that's the wrong direction. Along the same lines, and I've talked about Unicode, there's a very similar module called Unicode Data, which has a huge amount of data inside it. And you can find out all kinds of information about all the Unicode characters using this. And most of this is sort of newish, and certainly in the newer Python versions, you have the newer versions of Unicode. In particular, the data in this 3.3 is 610 of the Unicode standard. And you can see that I can look up, I guess the lights, I'm so bright now. It's worse. Anyway, I look up the coup character and I see that it's CJK Unified Ideograph 2008A. And I can find out some attributes about the character, and I can look up another character if I actually happen to know the name. Read the documentation on this, but this is just a module to think about. Here's a thing that probably, I won't, you can raise your hands or not, but I bet most of the people in the room have done this wrong multiple times over the years. If you want to run something in the shell, you want it escaped properly so that it can run in the shell. And it's easy to be lazy and not do it, and it's easy to try to scratch your head and think, yeah, what were the reserved characters in Bash, and what am I going to change those into, and where do I have to add some quotes, and where do I not have to, and you probably did it wrong. And the reason we've been doing it wrong so long is actually not because technically there wasn't a way to do it right, but because the way to do it right was undocumented and hidden in the pipes module, this function called quote, which you can probably find someone mentioning it on the internet somewhere, but it wasn't in the docs. So it's been moved over. Now it's in ShellX, which is sort of a better place for it, and it's actually officially stated to exist. And this is copied from the standard doc somewhere, this example, but you can see that you're going to call this thing and you're accepting user input and it's going to be terrible what happens. But something that I do a whole lot, which I don't know if other people do, is I actually write a lot of Python programs to generate Bash scripts. There's this sort of one-off task that I sort of want to do with a whole bunch of Bash commands, and I get the data and the logic about it from somewhere else, and but I still think it's going to be easiest to do. Maybe I'm going to do it more than just once, but I'm not going to do it a huge number of times. So I just, write out a bunch of lines to, do the thing.sh, and I never escape what I'm doing, and I probably it probably is subject to doing the wrong thing or possibly doing something malicious. So I don't actually even show it, but it just call quote before you use a string in the shell. And again, wrong direction. Okay, I have just a few minutes, but this is near the end here. How many people are using the old string interpolation, and how many actually use the format? Yeah. Who uses format? Raised. Looks like you do pretty good. You may not need the explanation, but the rest of you who didn't raise your hands should think about it too. I have a fondness for string interpolation, and it's the way that, we did things in C, and anyway, I've used it a long time. But format is cool. So let me pose here just a sort of ordinary problem. I have a bunch of numbers which I'm taking to be currency numbers. This is my, my credit card bill or something like that. And it turns out that I spend on my credit card rather divergent amounts. In some cases, I spend 9 million. Is that what that is? And in another case, I spend 2 cents. Because I'm, wild with my spending habits. And I'd like to make a little report of my spending habits, and okay, I can do it. I go through the different items, and I print out a line, and I put a dollar sign in front of it because I spend American dollars. And it looks sort of terrible because the dollar signs line up and the numbers are all different lengths. And, you could write a program to do that with string interpolation, but you'd have to write a support function to, I don't know, it would be tough. And you can do it better using the format mini language. And you sort of have to, I have 3 minutes left or something, I'm not going to be able to explain it, but there's a lot of these specifiers that say exactly how you want a string to be formatted once it's essentially interpolated. And in 3.2, I believe you don't have to name the sequential things that are in the curly braces. Before you had to call them 0, 1, 2, 3, and now it's sort of implied by their order if you don't bother with putting the numbers in it. So I'm making a line which I'm going to use as a format line, and first it's going to have any old thing with no particular format, and then there's a tab, and there's a dollar sign, and there's something that's going to be right aligned at 13 spaces, and it's going to be a floating point number with 2 decimal points. And I do that, and it looks okay. It looks a lot better than the last slide, right? But I actually sort of didn't quite like that because I didn't really like how the dollar signs were all lined up off to the left, and some of them were a long way from the figures of the amount I spent. And maybe someone in the questions can think of a way to do this in one pass, but as far as I can see, I have to sort of do 2 passes through format to do this. I have to kind of format the dollar figure, and then I have to do the alignment. But that's not too bad. I have this, purchase line, and I just say there's any old thing, which is the number of my purchase, and then the tab, and then there's the something or another that's aligned to the right at 14 spaces. And then the individual amount I format as a sort of generic floating point with 2 decimal points, which could be a string interpolation just as easily in that case, of course. And then I get, sort of the pretty output that I like. And it's really quite flexible what you can do with format, and it's sort of a complex language, but I'll jump through this a little. The email module has changed a lot and gotten better in Python 3.2. And part of it is dealing with bytes in Unicode, and part of it's dealing with some intricacies of RFC 2822. And getting this into place was a lot of work by David Murray, and part of that, the PSF gave some money to help him do that. So this is just really the end, but I just want to, I don't know if people played with the email module much, but it's pretty, and let me just show you a few things it does. We can import email, we can open this message from a file, which was actually an email I sent, actually. You can ask of the message what's its subject line and what's its content main type, and is it a multi-part message, and Oh, yeah, and what does have a subtype too, which in this case, this is something that you can see the values. It was called course progress. That was a multi-part message that is multi-part and is signed. And in particular, you can ask, well, okay, it's multi-part, so what is it that, that's inside it? Well, there's two parts, and both of the parts inside it are themselves these email objects, these message objects. So I'm curious of the oneth object, what type of thing is that? And it turns out that it's a PGP signature. So let's just take a look. That's what it is. I have a couple ellipses in it, but that's what I pull out. And, well, let's take a look at what the main part is. And again, I can get the payload and index, and then I can find out what keys it has, which are essentially the headers inside the subpart. And I see that it has those headers, and I can get the content type, and I can get the content disposition, and I can see that it's a TIFF image, and I get the payload, and I'm not going to, it's, thousands of bytes, but here's the first few bytes of the TIFF. So it's easy and fun to play with, and you can see how, programmatically processing and also generating on the other side is straightforward. Okay, date time has been improved. Some of this is the same. Timestamp is a nice new method of datetime objects. It tells you, not as a string representation or as a datetime representation, it tells you what time tells you, the number of seconds since the epoch. And that's nice that you can actually do that directly with a datetime object. I was trying to make a joke here, but I'm out of time. So you can all see that I wrote this slide 2 million seconds ago, and I was worrying about having only 2 million seconds left until I have to present. But the point was actually just that this total seconds is a new method of time delta, which is a nice new method. CSV has been improved, and HashLib has been improved. And HashLib in 3.2, you can actually introspect, in a sense, what's available and what's guaranteed to be available. That is to say, the first things, the algorithms guaranteed are going to be on every Python version that version of Python. And the ones that are on my particular machine are a bunch more, because whatever reason I have more. So that's it. The other stuff is cool. I'm not going to talk about it.
We've got time for a few questions.
Any questions? Everyone wants lunch, huh? Can you actually go to the mic, I think, because it's recorded.
So this is somewhat related to this talk, but maybe not particularly. What would be the best way to parse HTML in Python 3? What would you personally use and recommend? And not from theoretically proper way, but like practical, pragmatic.
Beautiful soup. I mean, that's the one-word answer.
Okay, thank you.
Because it's, I don't know if you've played with the module, but Beautiful Soup, which is not in the standard library, is sort of a very fault-tolerant HTML parser, that it gives you a kind of parse tree, and it gives you sort of DOM-ish methods to find things. But HTML in the real world, when you're reading real web pages, isn't really HTML. It's something that is sort of like HTML, but there's lots of things broken about it, and tags aren't closed, and things are misspelled. And Beautiful Soup sort of has this heuristic approach, and it generally gets things right.
Cool, thank you.
Was there another one in line, or just?
We've got time for one more question.
Thank you so much.
Thank you, David.